So good morning everyone, my name is Ryan Jacob Espitogo. Today we're going to discuss about a new data structure which are trees. To be specific, we're going to be discussing about binary trees, how to traverse them, and how to make an expression into a binary tree. So let's get started. So a binary tree is a kind of tree. So first we're going to explain about trees. So a tree is a structure that has children's and parent nodes. So this one here is gonna be our parent node, and this two is gonna be his direct children. So this means the parent plus has children's, asterisk and divide, or this is gonna be multiplication if you insist. So to check if this one is a binary tree or not, we're going to check if the maximum children is equal to 2 in every node. So let's check here from the bottom. We're going to check if each node has a maximum of 2 children. So it can be 0 children, 1 children, or 2 children, but it cannot go beyond that. So let's check. This row here, or this level here, has no children, so it is considered okay. This level has 2 children each, so this is okay. This level here has 2 children, so this is okay. This level has 2 children, so yes, and this level has 2 children. This means that this is considered as a binary tree. Now we're going to move about traversals. So how do we traverse a tree? So there are actually 4 methods in how we traverse a tree and access each nodes. So we have preorder, inorder, postorder, and level. So let's now begin on how to traverse a tree. First, we have inorder. So an inorder traversal follows a pattern of LVR, and this means that, let's open page first, is gonna consider the left node first, then the visiting, or this can also be the parent node, and then the right node. So how does this work in this large scale? So actually we're going to divide them into expressions. So this one is gonna be our greater the topmost parent. This is gonna be left, this is gonna be right. This can be a parent, so this is gonna be V. So this is the general gist of how the LVR works. So this is gonna be left and this is gonna be right. So we're just going to start here at the leftmost. So since this is divided into LVR, and this is gonna be this until it's gonna be divided like this, like that. Yeah, it's gonna be divided like that. If we consider every left, this is gonna be left, 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 left. Yeah, it's gonna be our lefts. So how does this work? We are going to be focusing on the lowest left here. So after we traverse, it's gonna have the notation like this. So why is that? So since we start at the leftmost, we're going to have A, and then the parent node of A is plus, so we put plus here. And since the right node of plus is B, so it's gonna be put here. So since we are done with this left node, it's now going to be this left node. So this is gonna be let me clear it first before we confuse. ourselves with that. This is LVR. Okay, so this is gonna be our new left. So let's delete that. This is gonna be our new left, and this is gonna be our new V. Why is that? Because we're done with this, and we're done with this, and the left of the divide operator is a plus b. Yeah, a plus b. This is gonna be left, right? So if we follow the pattern, so this is our v and this is our right. There, it's gonna be our right. So we're going to proceed with this, and when we proceed with this right, we're now going to check the leftmost node. So since the leftmost node is C, we're going to have C first, then this is gonna be the parent node. This is gonna be our right. So that's L, V, and R again. So what happens here is just the same thing that happened to this one. So it's gonna be having A plus B A plus B divided by C times D. So once we're done with that, we're going to proceed to a bigger expression. So this is gonna be V, and this is entire is gonna be R. So now we're going to add the multiplication sign in after D. So D multiplication. So after that, we're going to start at the bottom part. This is going to be LVR. So once this is now the new left, this is going to be V and R. And now this is going to be LVR, which leads us to a notation of E divided by F, and then plus G plus H. After that, we're done with this one. This is going to be our new L, this is going to be our new V, and this entire segment is going to be our new R. So what happens here? So since L is done, we are now going to have V. So V is plus, so after H we are going to have the plus sign, and then we're going to have the leftmost part of R as our new L. This is gonna be, and we're gonna work our way on the top. So this is LVR. So it's I divided by J, and then this is gonna be our new L. This is gonna be our new V. This is R. So this is gonna be after J. We're going to have the multiplication sign, and then we're going to have this as our new LVR. Yeah. So basically, we make the right as our new LVR. In each of these patterns, we are gonna always make the right the new LVR, especially if it has a lot of subtleties inside of it. So this is LVR. So it's now after J and multiplication sign, we're going to have K divided by L. L, and this is gonna be our new left, this new our V, and this is gonna be our new R. So the V is divide, so after L is gonna be the division sign, and after that we're going to have the leftmost. Let's label it LVR. This is gonna be divided into another L and another R. It's gonna be V. So this is L, so we are going to have M minus N. So this is going to be our new left, and then we have the visiting node, so M minus N, then have plus, and then we're going to have the right, which makes our new LVR nasat. So it's LVR, so it's O minus P. So that's how we get this notation using a preorder traversal. And now let's proceed to preorder. So a preorder traversal follows a VLR, or this means visiting node or parent node, then the left and the right. So Since we are starting at the visiting node, this is gonna be our first notation, and this entire part is the left. This is gonna be the right. Okay. So after the visiting, we are going to have the left. We're going to traverse the left subtrees and their parent nodes. So we're going to have this as our new V. This is gonna be our new L. This is gonna be our new V. This is L and R. So if we continue this, we're going to get this notation. So to explain, so we started with plus, and then we proceed to the multiplication sign as the left, and then we're going to traverse again to the left until we reach the leftmost part of the subtree. So this is multiplication, and then we are going to follow it with division, plus, and A. Since we traveled every left node, left node, we're now going to travel the right nodes. So let's start with the bottom. Since this is our current position, we're going to have now B, and then we're going to go back to the visiting node after R. Visiting node, this is going to be R. So in this, we are going to put multiplication, and then since we have a left node here, we're going to go first with the left node. So the next expression is going to be C, and then D. Since we're done with this part, we're now going to proceed with this visiting node, and then this is our R. So in this R, this has left nodes. So after putting plus, we're now going to proceed to go to the left. So go to the leftmost nodes. So this is going to be division, and then the next is expression E. And then once we're done with the left, we're now going to proceed with the rights. So the in our current position, the right node is F here. So after E is F, and then here we're going to go back and go to the right here, and we're going to have plus, then G, then H. And the same thing happens to since we're done with the left subtree, we're now going to do it in the right subtree. But it's still the same that we're going to traverse the leftmost nodes first before the rights. So after H, we're going to have the division sign, we're going to have the multiplication sign, division sign again, and I. And once we're done with this left subtree or the left parents, we're now going to go with the right parents. So J comes next, then the division sign. After that, it's gonna have the left children first, so K, and then L. After that is this one. After L, this is gonna be our new sub T, R. And then this is L, this is V. So we're going to traverse in the leftmost part. So this is gonna be the next notation, R. This is gonna be V, and then we're going to the left. So this is going to be next, and then M is gonna be next. And after M, we're going to proceed to the right parent nodes. So this means we are now going to move to N, then minus, and gonna be O first, then P. And that's how you traverse using a pre-order traversal. So Next is the postorder. So next is gonna be postorder. So a postorder notation follows a LRV pattern. So what this means is that we are going to start with the um, leftmost part of the subtree. The leftmost part of the subtree. Um, the leftmost part of the subtree. Then its right, and after its right is gonna be the parent node. So once we're done with that, we're now going to this LRV. No, this is LRV. So in a post order notation, we're going to start with the leftmost node. So this means we start with A. Wait, let me show you first the answer. It is for keeping track of the progress we are doing, and so that you can easily understand how traversal works in huge scales like this one, which has 1, 2, 3, 4 levels. So there. So we're going to start with A. This is our left, and then we're going to go with the right, LR, and then our parent node. So this means that our first expression is gonna be AB plus. There. This is gonna be our new left. This is gonna be our new parent, and this is gonna be our new right. So since this left is done, this is done, we're now going to proceed to the right. And within this right, there is a subtree. So we're going to still label it with L, V, and R. So we are now going to proceed to C. Let me circle this first. So since this stuff is done, let's circle it. Let's proceed to the right. And this right has a subtree in which we have to start with there, the bottom. So let's start with C, then D, then asterisk. Then since L and R is done, we can now consider V. So this is going to be divide. So AB plus CD multiplication sign, then division sign. This is going to be our new L. This is going to be our new R. This is going to be our new V. Since we're done with the left, we're now going to proceed to the right. And since it's right, we're going to proceed to the bottom and label them LVR, leftmost bottom, bottommost left, and then we're going to label them LVR. So we're now going to have E, F, and then division. EF division, and after that, this is now going to be a left, and this is going to be a V, and this is going to be an R. And since this is an R, we're with an R with a subtree, we're going to label it with LVR. So after this left, we're now going to proceed to the right, in which has G first, then R of H, and then plus. Since we are done with L and R, after plus, we're going to have another plus. And since L and R is done here, we're now going to consider this one, which is multiplication. So now that's done, we're now going to consider this as our new left, and this big one as our new right, and this is our new parent node. Since this left part is done, we're now going to proceed to this. And we're going to start at the very bottommost left. So this is going to be LVR. So we're going to have I, J, then division. And after that, this is going to be an left. This is V, and this is R. And since R must have an LVR, so it's LVR. So then we calculate K, L, then division, and after division is that multiplication. This is now going to be our new L. This is going to be our new right, and then this is going to be a new v. Yeah, this v is now calculated because it's now multiplication since L and R is done, and this is now gonna be LV and R. So since this left is done, we're now going to proceed to right, and we're going to start with the bottom most left again, LVR. So that's gonna be M, then N, and then division sign, and after that this is gonna be a left, our new left. This is gonna be our new R. This is gonna be our new V. So this is now gonna be an LVR since right has an this right node has what do you call this, children in the sub T's and sub T. So it's gonna be LVR. So after division, we're now going to proceed to the right, LVR. So we're gonna have O, E, minus, and then we're going to have plus, yeah, plus. And since this and this is done, we can now consider this one. So we're now going to have division, and after this we can now have this part because the left main sub 3 and the right main sub 3 is now done. We're now going to proceed to add this one as our last notation or expression. So this is gonna be plus, and that's why we get this expression here. Okay. And that's how you get post order. Now let's proceed to the last traversal method that we're going to discuss today, which is the level. So the level doesn't really follow a definitive pattern like what inorder, postorder, and preorder does, but it is actually on the title itself, which is level. So it is an order in which the order of levels from the leftmost to the rightmost is ordered. So this means that our first node is going to be the topmost level, which is plus, which is going to be plus, followed by left. Let's consider this left and right. So what's next is the next level, which starts with the left. So this is going to be, let me show you the answer first so that you can follow. So that's going to be multiplication, then division, and after this level is after this level is done, we're now going to proceed with this, which is this division sign first, then plus, then multiply, then plus. And after this level is done, now we're going to proceed to the next, which is plus, multiplication, division, plus, division, division, and minus, minus. And then this level is done, we're now going to proceed to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And that's how level traversal works. So after discussing the traversals, we're now going to explain to you how expression of a binary tree works. So how do we turn this expression into a binary tree? So first we're going to look at operation hierarchy of computer programming. So we're going to start with, of course, we're going to start with a logical NOT if we consider all things. Then arithmetic, which is considered with multiplication, division, and this modulo. Then it is going to have plus, minus, and this relational up till the assignment operator. And we're going to order them from the left to right. So we're going to start explaining it how we put them into a binary tree. So let's start. let me clear this first. Okay, so in an expression 8 plus 2 multiplied by 4 minus 3 divided by 4 plus 2, 23 times 8 1. So to explain on how to put this expression into a binarity, we're going to first start with the left and right until we reach the right order. So in this case, we're actually going to have the depth of the the depth of the nodes. So in each nodes, we're going to measure their depths. So we're going to start with the left first, diba? So since this is enclosed in a parenthesis, we're going to start with 8 first, which is has a level a depth of 0, and then since this is plus, this is an operation, so this is gonna be plus 1 of its predecessor, so it's gonna be 1. This is 2, so this is gonna be 0. And next, we're going to look at multiplication here. So since multiplication has lower incidence of this of this expression here, it's going to be at a depth level of 2. Yeah, it's going to be at the depth level of 2. And then since it is this notation is in a parenthesis, it has a higher precedence than multiplication, which means we're going to deduct the operation inside of it with 1. So this is going to be a depth of 1. Yeah, a depth of 1. And the expressions here are also deducted by 1. So this means this will be 0. This will be 0. So after that, we're going to proceed to the division. So since this expression will be expanded, like so this parenthesis will be multiplied to this, and then it's gonna be divided with 4. So this is actually gonna be a depth level of 3. Yeah, that is gonna be a depth level of 3. And then since this is the expression, so we are going to minus it with 1, deduct it by 1. So this is gonna be in an expression at a depth of 2. And that's how you get this until this. So now we're going to proceed in solving this one. So plus here is after 3, so this is gonna be a depth level of 4. So this is gonna be a depth level of 4, and then since this is in a parenthesis, we're now going to deduct them with 1. So now let's look at the operator here. So what's the next operator here? So the next operator here is actually multiply, because this is next to the plus. So since it is in a parenthesis and has a higher precedence, we are going to deduct it by 1. So this is going to be 3, and this is going to be, since this is its expression that is going to be multiplied, it's going to be deducted by 1 also. So it's going to be 2. So here, oh, I forgot to put a parenthesis here. So next is gonna be in this bracket. So what happens here? Since this is an operation lower than the multiplication, because it is enclosed with higher precedence, so this is gonna be 2. since it is minus 1, and this is gonna be 1. And now that we're done with that, we're now going to have this. So since this has a high precedence, because it is enclosed in a parenthesis, we're now going to have u 2 minus 1, so it has a def of 1, and this two expressions left are going to have a def level of 0. So now that we map the expressions, we're now going to put them into we're going to put them in order using this, since we can now visualize. So in our lower depths, we have 8. We're going to start with the left so that we are going to be systematic. So we're going to start with the left, so let's start with 8 plus 2, which is 0, 1, and 0. So this has 0, a depth level of 0. This is a depth level of 1. Next, we're going to proceed to the other part, which has the multiplication. So it is now going to have the multiplication sign is going to have a depth level of 2, and then the expression inside of it is gonna have a depth level of 1, the minus, and then 4 and 3 as 0. And then we're going to proceed with division. So it has division here, and then going to have the 4 is going to have a depth level of 2. And then we're going to proceed with the depth level 4, which is the plus sign. Yeah, the plus sign. And that's how it works. And then next is we're going to assign the multiplication, the operation inside the parenthesis. So we have the depth of 2 on the 23, and then a depth of 3 on the multiplication sign. And after that, we're going to proceed. So since we are done with the multiplication sign, we're going to proceed to this, in which we have the minus sign as a depth level of 2 and 1 as a depth level of 1. And then we're going to put the inside operations, in which is in before the minus of 1. So we're going to have 3 to the power of 2 inside minus. So we have 3 has a level depth of 0. The power sign is going to have a depth level of 1, and 2 is going to have a depth level of 0. And that's how we can solve an expression and turn it into a binary tree. And I guess that's everything. Thank you for listening, and God bless you all.